Hey everyone, I'm Kaitlyn Barnard.
And I'm Victor Gamov.
In this series, we chat with software developers and technology leaders to tackle your biggest API connectivity challenges.
Stay tuned to this episode for tools, tactics, strategies that will help you to take your distributed architectures to the next level. Let's begin. And today, I'm especially super excited to welcome Josh Long, a Spring developer advocate at VMware, and my friend, Josh. Welcome to Kongcast.
Oh, thanks, my friend. I missed you. I was saying yesterday when we were talking about this, I just regret we couldn't do this in person like we've done so many times before, you know?
Yes, but I'm super excited that technology like cloud and all this internet of everything can connect us still, and we have a great conversation. So, for those of you who don't know you as I do, can you briefly introduce yourself and what you do and what drives you, what's your passions and things like that?
My name is Josh Long. I work on the Spring team. I'm a developer advocate, a Google Kotlin developer expert, and a Java champion. And I spend my time trying to help people build better software intended for production in terms of Spring and the Spring ecosystem. And I've been doing that in my capacity as the first Spring developer advocate since 2010.
Yeah, 2010. I saw your first time, your presentation. You did this presentation in 2011 in New York. It was MongoDB office, and you were talking about the Spring Data project. I remember that.
You were there in New York in the Mongo Dev Day thing?
Yeah. It was a long time ago, and
that is so wild. That's a decade ago, man.
So, and there was great times, and the Spring actually went very long way since that time.
That was before Spring Boot, Spring Cloud, and all this stuff. Yeah,
exactly. So the thing exploded, and microservices world exploded around what, 2014, 2015?
Yeah, I would say around then. Yeah, and Spring Boot was super well positioned to tap into that zeitgeist. You know, the wave of innovation and excitement around agility and getting to production more quickly.
And I guess it was kind of like a perfect storm. Like people were looking for tools that allow them to break this monolithic application to build the services. And at similar time, many things happened. The Heroku released their 12-factor app manifesto, very famous one. And the folks at that time it was pivotal, right? It already was not the Spring source. Start working on Spring Boot. Can you briefly tell our listeners? Some of the listeners here are not that familiar with the Java ecosystem as we are, and like give us some rundown, like why it is exciting and how the Spring actually changed the way how the people develop apps in the Java world.
You know, it's very funny. Well, first of all, you're right about that. So there was Spring Source, then 2009 VMware bought Spring Source, then in 2013, Spring and Tomcat and RabbitMQ and Cloud Foundry and Gemfire and Redis and all these sort of developer-facing bits that were at VMware. We took all that stuff, Greenplum, we took all that stuff and like turned it into a new company called Pivotal. And I was part of that, first wave of new Pivotal. I was there on day zero, right? The very first day we opened our doors at Pivotal, I was an employee. So basically I had the same job, same team, same everything, just the name on the paycheck changed, and we created Pivotal, and that's when we created Spring Boot, and when Cloud Foundry got big as well, right? Because of again owing a huge debt of gratitude to the Heroku team, who inspired fleets of innovation, waves of innovation that still ripple today. It's funny you mentioned the people who may not know, because again, you're right. That's 2013, right? We're closer to a decade since Spring Boot's first 0.4 public release. That was middle of 2013. So that's a year and a half from now. Basically, it'll be a decade. But Spring has been lucky, right? Spring, as you know, and as maybe some others do, Spring is one of those very few projects that has been white hot popular 2 different times in its life, right? Like imagine if Struts, from 2000 came back today and it was like the most popular thing again. That's what happened with Spring. Spring came out, the first lines of code, you can see code in Spring from like 2000 or 2001. That was created by a gentleman named Rod Johnson, who wrote a book. He wrote a book about it that inspired others. The code in the book became an open source project that then became Spring. That inspired other people, including Jürgen Haller, who's still with the Spring team. He's still the lead of Spring Framework today. It inspired countless other people to hope for a better way to build software,
Right. Before that, it was just like a big application servers, like a big, like basically a representation of this like a monolithical application that we're trying to fight. And the Spring kind of paved the way, and everyone has followed. Like the many specifications that happened after emergence of Spring Boot, and even Spring itself as a framework, were affected by the ideas that Spring provided, like lightweight things that not super slow. Like people still thinking Java is slow, and we'll talk about this, like how this changed with the recent release of Spring Native. We're gonna talk about this in many details, but I wanna try to kind of create this kind of vision, and so people will understand that it's actually innovation happens, and the platform is not stagnating; it's actually evolving. And the microservices and the cloud and the serverless technologies that developers want to be agile, they want to be delivering the features, delivering their stuff to their users. They want to be like fast. They don't want to wait. They don't want to wait until everything will be running or starting up or things like that.
Right.
And things around Kubernetes and things around Heroku and Cloud Foundry. Like Cloud Foundry received a lot of inspiration from many worlds, and I super fascinated how it is actually evolved into something that can be very ambiguous, right? So you can run this pretty much like everywhere. Similar, like you can, if you want to run this on top of the Kubernetes, you can do that, or like you can use the Cloud Foundry as a foundation to run your Kubernetes and things like that.
Right. Well, so it's the other way around. Today, you would run Cloud Foundry on top of Kubernetes. So we have twist of fate, right? TLDR, Pivotal eventually got merged back into VMware after we went public and all that. I think VMware was sort of, I don't know what the motivation was, but basically it was to me, it seemed like they were really, really interested in becoming this developer first company. It was a very cool thing for them to do. And so the teams, the company of Pivotal and Heptio, right? Heptio was a Kubernetes company. And it's because of that, by the way, that we have two of the three founders of Kubernetes working at VMware. And we're all part, Heptio and Pivotal, we're all part of this division called Tanzu, Tanzu. So we have a Kubernetes distribution, one of the best in the business. We have Tanzu, we have Spring, and so Cloud Foundry now sits on top of Kubernetes if you wanted to, because Cloud Foundry is like an opinionated approach to building software. It's got guardrails, but if you use those guardrails, it's super fast, right? It's like Heroku in that respect. But still, something needs to manage the infrastructure, and nothing is better. Nothing in the world is better than that than Kubernetes. So yeah, it's an interesting mix. We've got a Kubernetes distribution. We help people build scalable, operationalizable infrastructure, and then we help them build apps that do well in that context, with Spring.
So the way how the Spring influenced some of the lighter version of everything from day one, like we talk about Tomcat, was lighter version of this like a gigantic application servers, like web spheres of the world, and the way how the Spring and the Tomcat and some of the dependency injection that Spring brought up changed the way how the people want to develop apps. Spring Boot changed the way how they want to develop apps in the modern world. They want to have a faster turnaround of the things, or they don't want to do like recompile. So that's why like a Spring toolkit that comes with the Spring Boot allows you to do this. You can change the code without doing restarts. Or my personal favorite part, integrating with third-party services in a very opinionated way. Things Spring Kafka, my personal favorite part of Spring projects. I use this a lot, and I taught this a lot and explain people how this stuff works, and gives some of the opinionated way how to connect to the services plus use the services in the Spring opinionated way. So Josh, what is the new and exciting just happened a couple of weeks ago, I would say, or it's actually started happening for a while, and people were more or less ready. But what the technology influence and help to move forward?
So, okay, to be fair, just to not to be technical about it, but to be fair, a lot of Spring, the best part about Spring is that we package up good ideas and good patterns into a way that's approachable for the community. So, as much as I love Spring Boot, and I think it's the coolest, nobody on the Spring Boot team would tell you that Spring Boot created everything by itself, right? Of course not. That's just not the case. So, for example, we drew a lot of inspiration from, for example, Dropwizard, right? Which had a lot of these great ideas before Spring Boot. We even used Dropwizard metrics in the first version of Spring Boot, the 1.x line. So I think that's what's really great about Spring is it's always been, we try and fill in the gaps if they exist. But if there's no gaps, then we just use and we just integrate the best of breed ideas and technologies and all that. So you can use Spring and all these other things. And that's what makes Spring so durable, is that it works well with these other things, like you just mentioned, the Spring for Apache Kafka project. And by the way, you and I have done talks on Spring for Apache Kafka and Spring Cloud Stream for Apache Kafka streams. That we've done talks on that kind of stuff, and I've learned a lot from you now. It's actually it's now to the point where I just look to your videos to learn stuff about Spring and Apache Kafka. So I appreciate that. Now, one of the things, I
appreciate you saying this. It's really I humbled.
Oh, thank you. So we're all grateful for the work you've done, and I am. One of the things that we've seen people trying to make work of late, and you mentioned this recently, is we've seen people trying to make Java work on GraalVM. Now, GraalVM is an ahead-of-time compiler. It's also a just-in-time compiler, right? So GraalVM is a piece of infrastructure that replaces Hotspot. If you use it just like that, as it was originally intended, the story that I heard, maybe this is apocryphal, I don't know. The story that I heard was that at some point they wanted to replace the just-in-time compiler Hotspot, which is built into OpenJDK, their project, the open source project. And that code is apparently a tangle of spaghetti C++ code that is hard to maintain. So they wanted to replace that with something that would be easier to understand and faster and all that. So they created GraalVM, which is an OpenJDK, which is it's exactly the same, except for there's a new just-in-time compiler. Instead of Hotspot, it's the GraalVM, just-in-time compiler. And a just-in-time compiler is a piece of secret sauce that makes Java so amazing, right? If you've ever run Java in production, you probably know that you can deploy an application, and as it gets more traffic, as certain code paths are executed enough times, they get turned into native architecture-specific binary code, right? x86 Windows or x86 Mac or whatever, specific binary code. So for certain code paths, you actually get native performance while you're running an interpreted language, right? And actually that, plus the fact that Java has a whole world view of the memory, right? You're not constantly having little bursts of memory acquisition and destruction because you don't have to do your own garbage collection. Because Java has this whole world view of the memory, it can clean up memory at the right time so that it doesn't cause disruption to the work that you're doing. So Java programs can actually be much faster than an equivalent C or C++ program, even a well-written one, just because of the benefits that we get from using this. So my impression is we've got this amazing just-in-time compiler, this native machinery, and I think somebody just said, hey, well, if we've got that, wouldn't it be nice if we turned it into what if we just compiled the whole application into
exactly. Why we need to have intermediate code? Why do we need to have a Java bytecode? And why we have a JVM if we so smart with compilers? Why we cannot just take instead of just in time, can we have ahead of time?
Yeah, exactly. And especially today, the original core conceit of Java, which is amazing, by the way, the original benefit. I remember I'm sure you remember too. In the 90s, when people talked about Java, you could write systems, well, not operating systems, but you could write big infrastructure and software that ran across all different operating systems, which is amazing. It is still amazing, right? That wasn't very common. The fact that you could have this nice, scalable, statically typed language that worked on all languages was great because people were developing applets and you didn't know what browser they were going to be using or what operating system. But today, all my cloud infrastructure is Linux in a container, right? It's
exactly
almost 99%, right? I don't know the number, but it's the very large majority of all infrastructure in production is Linux inside of a container. So really, while I want to run and develop on any operating system of choice, eventually I want to make sure it runs perfectly well in Linux in a container, right? And so,
right.
Yeah. So
maybe in specific version of Linux that has like a certain libraries, and probably you'd want to be small containers to run only required stuff, because storage might be expensive, or network bandwidth to moving these images back and forth would be expensive.
Yeah.
So, and this is where we're going into the interesting situation where, we still have a container to have a Linux, but on top of Linux, we still need to layer this
JRE
Java.
and and it's not cheap. I mean, don't get me wrong. Java is still amazingly fast at runtime, and the memory footprint is a lot more compared to some other languages. But it's not as bad as some other languages still. So if you're comparing against C or Go or Rust, then yeah, of course, your C or Go or Rust program is going to have a much smaller memory footprint. But try comparing it against Node or Python or something. You'll find those things take up a lot of RAM too. So if you're not trying to like eke out all that extra RAM, then maybe you don't care, right? If you're not doing Lambda, maybe you don't care. There's a lot of people who are just happy with the existing JRE state of affairs, and that's great because the JRE Java, the runtime it gets better and better for free every 6 months. It's like Moore's law still exists for Java developers somehow, right? It gets so good. I mean, if you take an application written today and start it up on different JREs, you'll see it's just it's just a night and day difference. That can shave almost a whole second.
One of the examples that I like to bring during the maybe a couple of years ago during the world when we were in transition to Java 8, Java 11, and make the Java more container friendly.
Yeah.
And like understand that Java can understand now that it runs containers, and it can absolutely understand that all this the limits that containers inform, and will not just like start grabbing out and saying, "Oh, I'm dying because there's not enough resources," or whatnot, or like the information that I get from my telemetry is not equal to reality. So in this case, it will try to figure out like, do I have enough memory to start this? I don't, so I will fall. Another thing that you said, like something that you're getting for free, the things around security, for example, and how TLS and support of the better the version of TLS and improving the encryption comes for free. So the people who were using the tools like, I don't know, like Kafka, Kafka, for example, and they use TLS and SSL there, by upgrading to new versions of Java, they got these improvements for free.
For free. And so, thank you, Java team. Thank you, Oracle. I know you and I are both very grateful and appreciative. And obviously, there's a lot of people that have, I think it's still the number 2 or number 1 largest community out there, right? A lot of people who have good jobs that put food on the table because Oracle does this amazing thing and they release it for us for free and open source even. It's even crazier. So it's wonderful. That said, there are still some use cases, like we say, that might be better served by having native binaries, right? In particular, production.
Or serverless.
Serverless is a huge use case there, right?
Yep.
Or if you're at scale. So people are keen on using GraalVM. And so a couple of years ago, back in I guess it's more than that now, almost 3 years ago, at the end of 2019, I would say, we started working on what could we do to make Spring a huge ecosystem work well in a GraalVM native image context. And by the way, from here on down, if I say GraalVM, just assume I'm talking about native images and not the JRE with the hotspot replacement. The question was, what can we do to make it work well in a native image context, a GraalVM context? This is only a question because GraalVM native images don't just work. They're not automatic. The problem, and I say this with air quotes here, the problem here is that Java applications can do all sorts of amazing things that GraalVM native images just can't yet, right? So for example, in a Java application, it's possible to type out the definition of a class file in a Java lang string. You have a variable Java lang string equals quote, 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 class my type, curly bracket, quote, 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 semicolon, right? You have literally a class definition in a string. You can take that string, compile it into a .class file on the disk, load that class file into the class loader, reflectively create a new instance with class.forName, and then create the new, call the new constructor, passing in the arguments. You can then invoke methods on that class. You can then serialize that class if you want, if it implements serializable. And you can then write that class to disk, or you can create an invocation handler, a Java proxy using that type that you just created, all from that string that you started with. So you can do all of that without ever having a concrete type. You're dealing with Java Lang object the entire time, right? There's no concrete type to which you can cast that resulting thing. And this is all happening after the application has started up. So the problem here is that Java is a very dynamic language. Sometimes we like to complain and say it feels like an old language, but it's really very dynamic, just like Python and JavaScript and Ruby and all that. You can do eval, EVAL, very easily in Java. It's not as easy as eval, but I just described things that you can all totally do within a Java program while it's running after it's been compiled and started. And because of that, the GraalVM approach, the GraalVM native image compiler, what it does is it looks at the code at compile time and tries to figure out what types are reachable. That is to say, what types it knows are being used by something else, but it can only see the types that are reachable at compile time, which means that all this other stuff that we're doing at runtime, like the reflection and proxies and serialization and loading resources from jars and all this stuff, it doesn't know about it. It doesn't understand it. And this is a big problem because so much of the Java ecosystem needs this stuff. It works on this stuff. It's what makes Java so dynamic and powerful, right?
Yep,
it's a reason
exactly.
This runtime is one of the beautiful things about Java. And so the GraalVM team, they're very pragmatic. They said, okay, fine. If you give us some config files that tell us when you're going to create proxies, when you're going to do reflection, when you're going to do all these things, we will make it seem like it works. Well, basically, they build in a little shim into the heap of the native image, so that when you say Java Lang, when you say give me a .class file and you call get declared methods, it doesn't just return null, right? It's a pre-computed sort of reflection API that only works for the types that you tell GraalVM about. If there's a way, then there's definitely a will, right? So now that there's a way, what we did was we built Spring Native. Spring Native is a compiler framework. It's a framework that runs at compile time. It knows about all the patterns that typical Spring applications follow, and it knows about all the
things that you just described, all the things around the reflection and how dependency injection works in the runtime. That's all these kind of like a nice, neat tricks needs to be documented somewhere, like in order to compiler to understand.
Right, and so we don't want you to have to write thousands of lines of JSON config files to tell it about every little place.
Yeah,
that's part one. Is we can make existing standard old Spring apps work on GraalVM using Spring Native, and that's been possible for more than a year now. What just happened recently, and to which you just alluded just like a few minutes ago, is we released Spring Native 0.11, which includes a new AOT engine. We've an enhanced AOT engine. We already had the AOT engine 6 months, a year ago, but this new part is very, very powerful. This new part is we actually take your Java configuration classes, your classes annotated with @configuration, and we transpile it into functional configuration. So now that whole discussion of which types are reachable at runtime, well, we don't have to provide the configuration. We don't have to provide configuration so that Spring can reflect on these Java configuration classes, because there are no configuration classes anymore at compile time, right? We turn it all into functional config, which is to say we programmatically register beans in the application context for you. And that's all reachable. That code is all, you can command click your way all the way through the graph and see what is happening where. And because of that, the compiled binary starts up, it takes even less RAM. It takes up much less time to start up. It's just amazing, right? And the compile time itself has gone down from, let's say, about 10 minutes in early 2020 to about a minute and a half now, or maybe even a minute, depending on what you're doing, right? I've had builds that take 50 seconds. So can I show you some of that? Okay, so, let's see here. I'm at start.spring.io. This is my second favorite place on the internet. Obviously, my first favorite place is production. I'm going to build a new application. I'm going to use Java 17. It's the technically superior version. It's also the morally superior version. You don't want your kids to find out that you're using Java 8 in production. The look of sadness and despair in their faces will it'll just depress you. So we've got reactive web support. We've got R2DBC, and we've got the H2 database, and we've got Spring Native. Notice that it says experimental, because remember, GraalVM is fairly new as well. So this whole thing is just a big, It's just all hopes and dreams at the moment, but it does work. So here we go. UAO customers.zip. I'm going to open this up in my IDE, and I'm just going to build a very trivial little HTTP application that talks to a SQL database. A SQL database, by the way, that is fully SQL 99 compliant and that I'm embedding in my Java program. So it's not just me connecting to another service. I'm actually starting up the database with the application itself because, you know what? Why not? We can do it. We have the technology. Okay, so I'm using Java 17, which means I can use nice features like records, I just love records so very much. And I'm going to create a Spring Data repository to manage read, write, update, and delete. So I'll say reactive CRUD repository, managing instances of type customer whose primary keys are type integer. And then I want to create a HTTP endpoint. So I'll say customer REST controller, and this is going to be a HTTP controller. So it's as opposed to like a MVC kind of thing. So I'll use response body there. And I'm just going to inject the repository to answer the question, given an HTTP GET, give me all the data, right? So inject that there, create a constructor, and we'll say customer repository find all. Now, this is my application, but of course, I need some sample data. And so I'm going to go here and I'll create a new file here called schema.sql. I'll say create table customer ID is going to be serial primary key name varchar 255 not null. Okay, good stuff. And we also want some sample data in there just to have something to look at, right? So we'll say data.sql. We're going to say insert into customer name values, and I want to do name, and we'll do Victor and Julia and Josh, and voila. Okay, there's our data. So let's go ahead and start this and see what that gives us. Okay, so let's go here. Let's just run this on the JRE. Okay, there we go. So there's my application up and running, localhost, customers, voila. That's the JRE, okay? So that's fine. We know the application works. Now, what I want to do is I'm going to turn this into a native image. Now, I have two paths forward. The Graalvm support, the Spring native support, has already been packaged into the application. I've got the dependency. I've got a Maven profile that I can use to compile to a native image instead of just a regular JRE application. And all the plugins have been configured. I can also build it into a Docker image. So I have two paths forward. I can build a native image, but I'm on a Mac, and that's going to be a Mac native image. Or I can build a Docker image that has a Linux binary inside of it. If I wanted to build a Docker image, I could do Maven Spring Boot build -image. That would work just fine. And that'll create a Docker image that I can then Docker tag and Docker push. But because it takes an extra 40 seconds, and it already takes a minute or so to build this. So what I'm going to do is I'm just going to build the native image. So I'll say Maven P native. I'm going to skip the test because our support actually compiles your tests into a native package, into a native binary, and runs the tests in that native context as well. And that takes an extra minute or so to compile. So I'll do Maven. I'm going to use the native profile here. I'm going to skip tests. I'm going to do clean package. And that's going to just do its thing in the background. It'll take, depending on the nature of the workload. Here we're doing a Zoom recording. And that's going to draw precious CPU cycles that I don't have to spare. So it'll go slower, but it takes anywhere from a minute to a minute and a half. Okay, first things first. Here's the resulting binary, 81 megabytes. That includes everything you need to run this. So you don't need the JRE. And in fact, you don't even need full Ubuntu. You could just do an Alpine Linux, a very small Docker image. So that's the application. Let's start it. Okay, 63 milliseconds. So 63 1,000ths of a second to start the application.
And think about this. This application. Let's test it on your URL request.
Yeah.
If it still has the data.
Curl HTTP localhost 8080/customers, and voila.
So now we think about this. This application also includes embedded database, SQL 99 compliant, includes some of the scripts that will populate this database. Yep. All this thing in one binary, and it starts in just a matter of seconds.
Milliseconds, not seconds.
Oh yeah,
thousands of a second.
Thousands of a second. So take that, serverless. No.
Yeah, and that's the other thing. Look at that resident memory footprint. So resident memory is basically the RAM that you're taking up. It's not the RAM that's being paged to disk. I don't think anything's being paged to disk here. Obviously, I've got 64 gigs of RAM, so there would be no reason to. But basically, this is the amount of memory that this process of mine is taking at runtime. It's 60, almost 70 megs of RAM. you could build a Docker image that has like a Linux distribution that takes 10 or 15 megabytes of RAM, size, footprint, and the binary itself is 70 megs, and it's taking 70 megs of RAM. That's amazing. And I've already worked recently. I've been working with MyBetas. I've worked with JobRunner, JOBRUNR. I worked on the Spring RetroSocket project. I worked on making Apache Lucene work with it, and making Common Mark, the Markdown parser. I mean, it's just all sorts of things for which, if you spend an afternoon, you might be able to figure out the delta between a working Jerry application and a working Spring Native application, even though they're doing weird things that Spring Native doesn't see out of the box.
Exactly.
The world's your oyster,
Yeah, you can also check one of the episodes of the Kong builders that I did, where I took the library that I love for generating some random data. I'm not that fast typer as Josh, so that's why I like to use libraries that will generate some fake data for me. So Java Faker actually also runs with Spring Native in one of my Kong builders, where I showed you key native integration, how you can deploy your Spring Boot application, how it will start just like immediately. And I also need to write a few hints, because it puts some of the resources on some unusual places. So all this kind of like the fake data that it generates, it comes from some YAML files, and those files were missing during compilation. So you need to specify like, okay, so that's where you need to look this, and please, dear Sir Compiler, ma'am, or someone, please include this in my application. That's something that we want to have. Josh, do you have any like final thoughts, or maybe like some of the resources that you want to share with our users, what they need to check out, or something if they want to learn a little bit more, or something just like inspirational that you want to share?
Spring.io/blog and spring.io/guides. You can find me on the internet, obviously, at StarbucksMan on Twitter. And thank you so much, Victor, for everything you do. I wish we could have done this together in person, like we've done in so many other countries and so many other places and so many other times.
We definitely will, because I believe there is some of the interesting topics that we want to discuss about the microservices as well. So I think it's one of the episodes where we start, and in future, I hope I will see you more and more. That was today's episode of Kongcast, where I have Josh along as Spring developer advocate at VMware, showing some exciting news from the Spring project and introduction to Spring Native. I hope you were excited and entertained same way as I did. I would like to say huge thanks to Josh for being on the show.
Thank you.
And we will see you on the next time. My name is Viktor Gamov, and as always, have a nice day.
Thanks to everyone out there for watching. I hope you enjoyed today's episode as much as we enjoyed recording it. Make sure to hit that like button now.
And be sure to subscribe so you don't miss a new episode.
Don't forget to drop us a comment if you have any questions for today's guest, or if there's a topic you'd like to see us cover in the future.
And we will see you on the next episode of Kongcast.